What if we're already inside a black hole? Picture this. You're sitting in your kitchen, sipping coffee, scrolling through your phone. Above you, the ceiling. Below you, the floor. Around you, the comforting solidity of an ordinary morning. Now what if I told you that all of it? The kitchen, the coffee, the planet under your feet, the entire observable universe stretching 93 billion light-years across, might be sitting inside the belly of a colossal black hole. And what if some of the strangest data ever returned by the James Webb Space Telescope is making serious physicists wonder if that's actually true? Stay with me. Because this idea sounds like science fiction, but the math has a habit of refusing to go away. So what are we even talking about here? Black hole cosmology is the proposal that our entire universe, every galaxy, every star, every atom, exists inside the event horizon of a black hole that lives in some larger, parent universe. The Big Bang in this view wasn't a cosmic beginning so much as a cosmic doorway. Something fell into a black hole somewhere, somewhen, and we are what's on the other side. It's a wild claim, but it isn't fringe nonsense dreamed up on a podcast at 3 in the morning. It's a serious hypothesis that's been quietly developed by theoretical physicists for over 50 years, beginning with Raj Kumar Pathria and the mathematician J. Good in the early 1970s. And in the last few years, it's gotten a strange new burst of attention. Let's start with the coincidence that won't go away. If you take all the matter in our observable universe and ask, hypothetically, what would happen if you crushed it down into a black hole? How big would that black hole be? The answer is a number called the Schwarzschild radius, the size of the event horizon for a given mass. Now compare that number to the actual radius of our observable universe, often estimated using something called the Hubble radius, roughly 14 billion light-years. Here's the unsettling part. They're nearly the same. The math works out almost exactly. If you collapsed everything we can see into a single black hole, that black hole would be about the size of everything we can see. Most physicists, including the well-known cosmologist Sean Carroll, point out that this is partly a mathematical inevitability for a flat universe, a consequence of how the equations are set up rather than proof of anything spooky. But it's still a haunting little fact. It's the kind of coincidence that makes theorists scratch their heads at 3 in the morning. Then there's the deeper resonance. Both black holes and the Big Bang, according to general relativity, contain singularities of points where matter is crushed to infinite density, and the laws of physics, as we know them, simply stop working. The Penrose-Hawking singularity theorems pulled this out of the math decades ago. Now, run the Big Bang backward in time. Everything in the universe gets squeezed into a smaller and smaller volume, hotter and denser, until you hit a point where space and time themselves break down. That sounds suspiciously like the singularity at the heart of a black hole. The Big Bang is a singularity in our past. A black hole is a singularity in someone's future. So is it really so crazy to wonder if they might be the same kind of object, just viewed from opposite sides of the event horizon? Here's where it gets even stranger. In March of 2025, a researcher named Lior Shamir at Kansas State University published a study in the monthly notices of the Royal Astronomical Society that set the internet on fire using the James Webb Space Telescope's Advanced Deep Extragalactic Survey. He analyzed 263 early universe galaxies whose rotation direction could be clearly identified. According to standard cosmology, in a universe with no preferred direction, you'd expect roughly half to be spinning clockwise and half counterclockwise. That's not what he found. About 2/3 of those galaxies were rotating one way and only 1/3 the other. Shamir offered 2 possible explanations. The first is mundane. Maybe it's an observational bias caused by Earth's motion through space, distorting our view of distant galaxies. But the second explanation is the one that made headlines around the world. He suggested the universe itself might have been born rotating. And a rotating universe is exactly what you'd expect if our cosmos were the interior of a spinning black hole. This is where a physicist named Nikodem Poplawski enters the story. Poplawski works at the University of New Haven, and he's been developing this idea for years, drawing on a modified version of general relativity called Einstein-Cartan theory. In standard general relativity, when matter collapses into a black hole, it just keeps collapsing forever into a singularity. But Poplawski's math suggests that the intrinsic spin of fundamental particles creates a tiny repulsive force called torsion. Under normal conditions, torsion is so weak you'd never notice it. Squeeze matter to densities far beyond anything inside an atomic nucleus, however, and torsion suddenly becomes powerful enough to halt the collapse. Instead of forming a singularity, the falling matter bounces. And on the other side of that bounce, a brand new universe begins to expand. Sound familiar? In Poplawski's hypothesis, our Big Bang wasn't a beginning at all. It was a rebound. Stuff fell into a black hole in some larger, older universe, hit the floor of physics at the bottom, and exploded outward into the cosmos we now call home. Now, a healthy dose of skepticism is required here, because plenty of very smart people think this whole idea is wrong. Sean Carroll has written that the universe doesn't really behave like a black hole in any meaningful sense. A black hole, by definition, is a region you can't escape from because there's no outside. Our universe doesn't seem to have an outside in the same way. The Big Bang singularity isn't a point in space the way a black hole's singularity is. It's a moment in time, sitting at the start of every observer's history, and critics of the Shamir galaxy study have pointed out that earlier surveys of millions of galaxies have shown a much more random spin distribution. As Scientific American put it, we probably don't live inside a black hole, and there's no compelling evidence, yet that we do. The cosmic microwave background, that faint, ancient afterglow from the universe's infancy, is uniform to roughly 1 part in 25,000 in every direction we look, which is exactly what you'd expect from a smooth, non-rotating universe. So far, the simple, boring explanation is winning. But here's why the question still matters, even if the answer turns out to be no. We don't actually understand how our universe began. We don't know what dark matter is, or what dark energy is, or why the cosmos seems so suspiciously fine-tuned for the existence of stars and chemistry, and us. Black hole cosmology is one of several attempts to take the deepest mysteries of physics, singularities, the information paradox, the holographic principle, where Stephen Hawking proposed that the entire three-dimensional contents of a black hole might be encoded on its two-dimensional surface, and stitch them into a story about how reality itself is built. Even if it's wrong, it's the kind of wrong that helps us understand what right would have to look like. And every time the James Webb Space Telescope sends back another batch of impossible data, the boundary between what's mainstream and what's heretical shifts a little. So the next time you look up at the night sky, try this on for size. Maybe you're not just looking out into a vast, empty cosmos. Maybe you're looking at the inside of something, a horizon, a boundary, the walls of an enormous, ancient cell of space and time, with another universe somewhere on the outside, completely unaware that we're in here at all. Probably not, but maybe. And isn't it wonderful that we get to ask the question? If you enjoyed this little walk to the edge of cosmology, hit subscribe, leave a comment with what blew your mind the most, and let me know what cosmic question you'd like us to tackle next. Until then, keep looking up, even if up turns out to be in.